Hello and welcome to Mrs. Law's class. In this lesson, we're going to review squares and square roots. Now, you probably know a square from even back in elementary school that it is a shape with the sides equal. So we can say that this side length is equal to this side length, and that's what makes it a square. So in this square, the side length is equal to 3 on this side on the bottom, and the side length on this left side and right side is also equal to 3. So we can find the area of the square by going 3 times 3, and we get 9. Now we can also count the individual little squares inside, and we can see that we have 9 little squares that make up the bigger square. Now the relationship between the side length and the area is that I take the side length of a square, and when I multiply it by itself, it equals the area of the square. Now this area can be thought of as a square number. Now when the side lengths are rational numbers, the square number can also be called a perfect square. All right, now we can write this in many different ways. We can use words and we can also use mathematical notation. So in words, we can say that it's, for example, 6 times 6 is 36. Symbolically, we can go 6, use the times symbol, times 6, and that equals 36. We can also say 6 squared is 36. So that means we're taking 6 and we're making it into a square, and we get 36 little squares. Symbolically, it looks like this, 6 with a little 2 written in the top right corner of the number, and that equals 36. So we can say 6 squared equals 36, but we can also say in words the square of 6. So the square of 6 is 36. Now, I've listed here the first 20 perfect squares. You probably know the first 12 just from knowing your times tables. And 20 squared is probably pretty easy to remember since it's 2 times 2 and then 2 zeros added at the end. So it is nice to have these memorized so that you can actually recall your squares quickly and we can do other things with them later on. All right, now that we've taken a look at squares, let's take a look at square roots. So the process of undoing or reversing the squaring process to find the original number that we used in squaring is called finding the square root. So you are trying to find the number that when you multiply by itself, it gives you that square number. Now you can also think of it as finding the side length of a square, and I find that actually very helpful. So if you're given the area of a square, the square root is actually finding the side length. Now, finding the perfect square and finding the square root, these are opposite operations, and they are called inverse operations. Other inverse operations include multiplying and dividing, and also adding and subtracting. Now, the symbol for square root is this little, kind of like a check mark, with a line on the top that indicates everything underneath is what we're going to square root. So for example, let's say that we have the square root of 81. So ask yourself, what number multiplies itself to equal 81? So remember to think of 81 as the area, and we know that 9 times 9, being the square side length, will give us the square root. So 9 is a side length, and therefore the square root of 81 is equal to 9. Now, what about if we were trying to find the square root of this fraction? Well, let's pretend that this square that we have here is actually not 3, but let's say that this is actually a length of 1. Okay. So knowing that this is a length of 1 and our area is actually 4/9, So we know that we have 9 squares in here. We're going to color in 4 of them. So I'm going to shade in 4. Okay. So this represents the fraction 4/9. Okay. Because 4 squares are shaded out of 9. So only looking at the blue shaded area, what is the side length of this blue shaded area? We can see that this length here is 2/3 of 1. So 1 is the entire side length, but just the side length of the blue part is actually only 2/3 and 2/3. So that means that the square root of 4/9 is 2/3. So let me write this out. So we went and took 4/9, and that is the area. Okay. And then what we're going to do is we're going to shade 4/9 to make a square. Now we're purposely making a square. We're not shading an L shape, or we're not shading one straight line down, but we're shading 4/9 to make a square. And then the side length of the shaded square is 2/3. And that's what makes the square root of 4/9 to be 2/3. Now, what happens if the number that we're trying to square root is a decimal? Well, sometimes people get tricked because they think it's, for example, here we have like, oh, it's 5 times 5, so maybe it's 0.5 times 0.5 or whatever. So what we're going to do is, I recommend that you change it to fraction form, okay, and then evaluate it after. So for example, we have 0.25, and that is the same as the square root of 25 over 100. The reason it's over 100 is because when we look at the 5 is in the 100th place. Or you can also think of this as there are 2 numbers after the decimal, so therefore we're going to put 2 zeros. Now we can square root 25, and we can also square root 100. So we're going to square root each separately. Square root of 25 is 5. And then in the denominator, we square root 100, and that's 10. And then we can reduce this to half. So actually, indeed, the square root of 0.25 is actually 0.5. All right, what about the second one? That looks like it might also be something around maybe 0.5 or 0.05. So again, let's change this to a fraction inside. So this will be 25 over 1,000 this time. And the reason it's 1,000 is because the 5 is in the 1,000th place. 0 is the 10th, 2 is the 100th, and 5 is 1,000th. Now we can also think of this as there are 3 numbers after the decimal, and so we're going to place 3 zeros. Now in this case, we can square root the 25, but we can't square root 1,000 because there's an odd number of zeros, okay? So denominator cannot be square rooted, and therefore, so a therefore symbol in math is these 3 little circles in a triangle. So therefore this square root is not going to give us a rational number. We'll get an irrational number, but what we want is rational numbers when we square root. And that's how you take the square root of a decimal number.